tautomerism, Aditi or Ranjan? What is meant by the tautomerism? What is meant by the tautomerism, Anjan?
A compound like which has more like structures.
More like structures. Compounds are having same molecular formula, and
Molecular formula same, and they have like more
they convert.
structures.
They easily convert from one form to another form.
Another.
Okay, so how they convert very easily from one form to another form? Yeah, by shifting of the pi bond.
Hydro. Okay, I
Okay,
got.
shifting of the pi bond. So what is another name of the tautomerism? Another name of tautomerism. I give some names. Aditi, what is another name of the tautomerism? So tautomerism. Yeah.
I don't remember.
Ma?
I don't remember.
Ma. So here tautomerism also we can call it as a ketoenol tautomerism. Okay, and what is another name of the tautomerism? If tautomerism also we can call it as a desmotropism. Okay, on screen only it is there. Okay, what is another name of the tautomerism means here? Tautomerism also we can call it as a desmotropism. Okay, and one more question, sir. If you compare with the ketoenol tautomerism, which one is more stable? Either ketone or enol formation? Acetone, my I had given acetone. Acetone is converted into the enol formation. Okay, so simply I'll give one more structure to you. So I'll give one more structure. Yesterday I think so I'm discussing about the hydrogen bonding. Is it right? So there we stop. Anyway, I'll ask some question mark here. So first, the given example is the given molecule is it exhibit as a tautomerism or not? First, any one of you. Otherwise, sir, we are having confusion and why you can't give the simple structure means. First, I'll start with the simple structure only here. Sir, CH3 bond, C double bond O bond COOH. COOH. Whether the given compound is exhibit as a tautomerism or not. Any one of you? Aditi, Anja, then who are there? Samita, also my guess correct only. Sir, Samita, whether the given molecule is exhibit as a tautomerism or not? Sir, the given molecule is exhibit as a tautomerism. Sir, how you are telling that the given molecule is exhibit as a tautomerism means here, once you checked out all of you, sir, here the compound is having ketone functional group here. It is having here ketone functional group. So ketone functional group neighboring carbon is called as a alpha carbon. Alpha carbon is contain the alpha hydrogens. How many alpha hydrogens are there this carbon? How many alpha hydrogens are there at this carbon atom? So it has 3 alpha hydrogens. So to make you understand, I'm going to write like this here. So when this hydrogen is shifted towards the oxygen and pi bond is shifted in between the carbon and carbon, then only it is converted into CH2 double bond, C bond OH, bond COOH. In this structure, my question is, so this we can call as a keto form and this we can call as a enol formation. In these two, which one is more stable? That is my question. In the two, which one is more stable? Either keto form is
Cause ketone, sir.
very good, sir. So keto form is more stable than the enol formation. Okay. Now one more question, sir. Sir, I give one more example here. So either the given molecule is exhibit as a keto tautomerism or not. Cyclohexanone I had given. Is cyclohexanone is it exhibit as a tautomerism or not?
Yes, sir.
Very good, Ajay. Next, Aditi. Aditi, is cyclohexanone is it exhibit as a tautomerism or not? Aditi, Samhita,
No, sir.
no. And Sriveda, Sriveda, that the given molecule is it exhibit as a tautomerism or not?
Yes, sir.
Samhita, everyone is except Aditi.
Sir, I think no, sir.
Ma, you don't know.
I think no, sir.
Okay, so two members, no remaining two members they said as, let us see, ma. The given compound is exhibit as a tautomerism because of it is the ketone functional group. This carbon it is there. Carbon and C double bond O. Okay, carbon C double bond O. In this one, if you observe means here, sir, the carbon is containing two neighboring carbon atoms. The two neighboring carbon atoms are called as a alpha carbon. Okay, the two neighboring carbon atoms are we can call as a alpha carbons. Okay, so today system is very slow. I don't know what happened. 1 second. I'll write here. So here one hydrogen atom. All of you, are you getting my voice? Everyone, you getting my voice now?
Yes, sir.
Here I don't want to write that. So this is the cyclohexanone. Okay, C double bond O it is there. So this carbon also we can call as alpha carbon. This carbon also it is called as alpha carbon atom. This carbon is attached with the two hydrogens. Okay, this carbon is attached with the two hydrogens, and this carbon also it is attaches with the two hydrogens. Okay, if it is attaches with the two hydrogen means one hydrogen is going to be shifted like this now, and double bond is shifts in between these two carbon atoms. When the double bond is shifts in between these two carbon atoms means it forms as a enol formation. If it forms as a enol formation means that we can call as a tautomerism only now. So this is the product you will get. Hence, the given molecule is exhibit as a tautomerism. Okay, can I give one more example to you? Right, sir. I'm giving one more example. What is another example means? Whether the given molecule is exhibit as a tautomerism or not. Whether the given molecule is exhibit as a tautomerism or not. Any one of you. So all of you have idea about the lining structures now. Everyone.
Sir, I think no, because there is no alpha carbon present.
Very good, Samhita. Very good answer. There is no alpha hydrogen. If there is no alpha hydrogen, means they does not exhibit as a tautomerism. Okay, sir, because of the single lines are okay. So all single lines are they represent as a methyl group only. Here also one methyl group is there. Here also one methyl group is there. Here also one methyl group is there, and here also one methyl group is there. There is no alpha hydrogen. If there is no alpha hydrogen, means it does not exhibit as a tautomerism. Okay, it does not exhibit as tautomerism. Okay, can I give one more example to you? I'll give one more example to you, ma'am. Aditi, you got the clarity now?
Yes, sir.
Okay. Now, Aditi, question for you. The next question is for you. Next example is for you. Okay. Now, Aditi, is the given compound is exhibit as tautomerism or not? Is the given compound is exhibit as a tautomerism or not? If it is exhibits means which carbon is involving in the tautomerism. That is also you have to explain. I'll give the numbering. 1, 2, sorry, 2, 3, 4, 5, 6. This is the structure. So now my question is, which carbon is involved in a tautomerism?
Sir, is it the sixth carbon?
Very good, Aditi. Okay, so sixth carbon is exhibit as a tautomerism, sir. So because of, sir, if it is second carbon is involved in a tautomerism means two double bonds, sir, you will get alternatively, sir. If two doubles are present side by side, means they have a unstable, they become as an unstable. So which hydrogen is involved in the formation of the tautomerism means here sixth carbon. Okay, hence if the sixth carbon hydrogen is involved in the tautomerism means product you will get like this. Okay, product you will get like this double bond and OH. This is also we can call as a enol formation tree. Okay, and one more structure. I think so. I had seen this question some previous paper, mains level only. This is the one more example, sir. Okay, is the given example is it involves in the tautomerism or not? Is the given molecule is exhibit as a tautomerism or not?
Sir, it will not.
No? Think. Next, any one of you? Anjan?
Will it form a benzene? Phenol?
Very good, Sangeeta. Okay, it forms as a phenol, sir. Sir, how it is involved in the tautomerism? Which hydrogen is involved in the tautomerism means here, let us see. Here, first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Okay, in this one at fourth carbon atom, if you observe means here, two hydrogen atoms are there. Remaining all the places we have a one hydrogen atom only. Sir, you may get the dot. I hope so, everyone you may get the dot. Sir, here first carbon and fourth carbon atom. How the hydrogen is migrates from fourth carbon to first carbon means we have a conjugation. We have a conjugation. Sir, what is meant by the conjugation? Any one of you? Can you please explain me, sir? What is meant by the conjugation?
Alternative bonding.
Very good, Veda. Okay, alternative single bond, double bond. Okay, sir, from where we can check it out means from the ketone functional group we have to check it out, sir. After the ketone functional group, single bond is there. After that, double bond is there. After that, single bond. So from this hydrogen is migrates to oxygen. If this hydrogen is migrates to oxygen means here, sir, double bond adjustment will happen. Okay, rearrangement it will happen. By rearrangement, finally it forms as a product is phenol. What is the product we'll get as here? Phenol. Okay, so
Sir,
this
is it also because of resonance?
yeah. So because of resonance only, Samhita? Because of resonance only. Okay. So based on the migration in between the number of atoms also again tautomerism also dyad, triad and at all we are calling. Okay. So simple example. Simple example altered. Okay. So what is the simple example means here? No. So here one example. If had C triple bond N. So this also I can write as here H N triple bond C also we can write. So what's the difference it is that in these two structures? What's the difference you are observing in these two structures? In the first structure, hydrogen is going to be attached to the carbon. Is it right? And the second structure, hydrogen is going to be attached to the nitrogen atom. The second structure, hydrogen is going to be attached to the nitrogen. Okay, in the second structure, hydrogen is going to be attached to the nitrogen. If the second structure, hydrogen is going to be attached to the nitrogen, means hydrogen is going to be changes in between two atoms. How many atoms are there? It is exchanges in between two atoms only, na? If it is exchanges in between two atoms means that we can call it as a dyad. That we can call as a dyad. Okay. Now in the above structure, in this example, okay. Oh, sorry. Right. So in this example, here if you see, so you are telling that hydrogen is going to be migrates from these carbon atom. Is it right? H it is there. So here to here, in the migration of the hydrogen from this carbon atom to oxygen, total in between, how many atoms are there? Here, 1, 2, 3. Okay, so hydrogen is migrates in between three atoms. When the hydrogen is migrates in between three atoms, means that we can call as a triad. Okay, if the hydrogen is migrates in between three atoms, means that we can call as a triad. Okay, now in this one, hydrogen is migrates in between how many atoms, ma? From here to here. 1, 2, 3, 4, 5 atoms are there. At the same time, they have a conjugation. Okay, conjugation means so due to the presence of the alternate double bond, single bond means here. So they undergoes to the resonance. Okay, they undergoes to the resonance. So due to the presence of the resonance only, so last structure it exhibits as a tautomerism. Now you got the clarity, all of you, everyone. Okay, and sometimes they're asking the questions based on stability. Okay, so sometimes they're asking here, so based on stability. Sir, all single one, if the one ketone functional group it is, that means, so keto group is more stable. Okay, keto group is more stable than the enol formation. If it is having more than one ketone functional group means which one is more stable, and how we can explain the stability, sir? Now, for example, let us see if I wrote one example here. C double bond O C double bond O bond CH3 bond CH2 bond C double bond O bond NH2. But this is the one structure I had given. First of all, the given molecule is exhibited as a tautomerism or not. First, any one of you. If it undergoes the tautomerism means which hydrogen is it undergoes to the tautomerism. That is also you can expect. So then I'll give the numbering for you. 1, 2, 3, 4. Okay. So the given molecule is exhibited as a tautomerism or not. Sriveda, Samhita, Anjan, Aditi, and one more. Sai Akshita.
Yes,
What
sir.
is-
It will.
Aditi, you are giving some answer. What is the answer? Aditi, what's the answer? Which hydrogen is involved in the tautomerism? Anjan?
So the second one.
Very good one.
2, sir.
Second one is second hydrogen is more reactive, sir. Then second one is involved in the formation of the tautomerism. So if the second hydrogen is involved means that we can write as a structure is like this: OH double bond C bond CH3 CH bond C double bond O bond CH3. Okay, you got the clarity, sir. So this is the enol formation and this one is the ketone formation. Sir, in this structure, so which one is more stable? Either the enol formation or ketone formation is more stable. Which one is more stable? Aditi. Anja.
Yes, sir.
Sir, is it ketone?
No. Not ketone. Aditi, which one is the stable formation? More stable. Either ketone form is more stable or enol formation is more stable in this structure.
Sir, enol formation.
Very good. So Aditi, why it is the enol formation is more stable? Samhita, why the enol formation is more stable? Aditi is telling that enol formation is more stable. Sriveda, yes, ma, somebody they are giving an answer. What is the answer? The enol formation is more stable because of it forms as an intramolecular hydrogen bonding. Okay, it forms intramolecular hydrogen bonding. Hydrogen bonding. Intramolecular hydrogen bonding. Sir, at the same time, one more thing. Sir, all of you, did you remember resonance structure? If the number of resonance structures are increases, what about the stability? Stability is going to be increases or decreases, sir? If number of resonance structures are increases, stability is going to be increases or decreases? Any one of you? How many members knows about the resonance? Aditi, do you know about the resonance?
Yes, sir.
About college.
Ma?
About college, sir.
It's not about the college. I'm talking about the stability. Stability we can explain based on the resonance structures. Okay. So actually, whenever you're studying the aromatic compounds and all, okay. So that we are going to be explained based on the resonance. Resonance is nothing but delocalization of the pi electrons. When the pi electrons are delocalized on one carbon atom to another carbon atom, we get as some new structures, especially benzene. So benzene is exhibit as a resonance structures. More all aromatic compounds are they exhibit as a resonance structure. Number of resonance structures are increases. Their stability also is going to be increases. Okay, so for example, if I had given, if you compare this one and along with that one more example I'll give you, sir. Here pH bond C double bond O bond CH2 bond C double bond O bond CH3, sir. Any one of you. Sir, now my question is here, first one and this is the second one. In the first one and second one, which one is the more stable? First one and second one. Aditi, Anjan, Samhita, Sriveda, Madhusudan. Two structures I had given. In two structures, which one is the more stable? If it is stable, means why it is the more stable? Aditi, do you know the answer? Say yes sir, no ma.
No, sir.
Anjan,
No, sir.
Samita, this is the JEE level concept. That's why I'm focusing a little bit.
Yes, sir.
Don't mind. So, Samita, which one is the more stable in this one? Which structure is more stable? Sir, okay. I don't want to waste your time. Sir, second one is the more stable. Sir, why the second one is the more stable means here benzene ring it is there. Okay. If it is a benzene ring means the given structure is it undergoes to the resonance. Resonance means it forms as a more number of structures. Number of structures are increases. Their stability also is going to be increases. Okay. Sir, I can write one more structure also like this only. Okay. What is the another structure I can write means here? Sir, third structure also I can write like this here. So to make you confused, I can write like this also. Bond C double bond O bond CH2 bond C double bond O bond. I'll write like this. In this one, pH is nothing but benzene ring. pH is nothing but benzene ring. pH is nothing but benzene ring. So I had given three structures. First structure, second structure, and third structure. So which one is the more stable means here? Third one is the more stable than second one. So that means how we can write as a stability order, decreasing order means here. So third one is more stable than secondary. So second one is more stable than the primary one. First structure. Okay. Sir, how you are telling that means in this one you will get as a more number of resonance structures. First of all, how many members do you having clarity about the resonance? Except Aditi. Aditi is telling that she is having clarity about the resonance. Remaining all of you. Anjan, Samhita, Sriveda, Madhusudan. Do you have any idea about the resonance? If you don't have means, I'll explain sir once.
Yes, sir.
If I have idea about the resonance, ma? No. Anyway, once I'll explain, ma. So one I'll take as a benzene ring. Okay. So first I'm taking as a benzene ring. Sir, benzene ring is having alternate double bonds. Okay, it is the benzene ring. Let us see, sir. So how the electrons are delocalized means. So when these pi electrons are shifted on this carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. Okay, so first, if the shifting means here, you will get as one carbon is will get as a negative charge, another carbon is will get as a positive charge. Okay, and the second one, when these pi electrons are shifted on this carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. In between the positively charged carbon atom and negatively charged carbon atom, new pi bond is going to be formed. So whenever it forms as a new pi bond, you will get as a new structure. Okay, so this, and here also negative, here also positive it is there. Here one more bond it is there. Again, when these pi electrons are shifted on this carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. Again, in between the positively charged carbon atom and negatively charged carbon atom, it forms as a new bond. It is formed as a new bond. Okay, and you will get it. Here also negative charge is there. Again, here also positive charge is there. In between, so positive and negative, it forms as a one more new bond. Okay, forms as a one more new bond. So first structure and second structure. So first and second structures are we can call as a resonance structures, and all these are we can call as a canonical structures we can call. Okay, all are having nearby similar resonance energy, it will be there. Okay, now by delocalization of the pi electrons, we have a 3 pi bonds. Due to the presence of the 3 pi bonds, total how many structures we got? How many structures we got, man? How many total resonance structures we got? All these are we can call as a resonance structures. How many resonance structures we got? Total. You're not answering. No one is answering.
So can you repeat again?
Ma?
So can you repeat again? Your voice was breaking.
My voice was breaking, ma. Amma, when the benzene is, it undergoes to the resonance, the total number of resonance structures form.
So there are two.
2 or 5. 2 or 5.
So two because there are only alternate bonds. So yeah.
Total will get as total 5, ma. 5 new structure. Actually, it is just delocalization I am showing here. So totally, if you take means totally you will get as a 5 structures we are getting. But exactly, what is exact means this one we can consider. But generally by the delocalization means here. So resonance means delocalization of the pi bonds, delocalization of the pi electrons. Okay, so in all the carbon atoms, electrons or pi electrons are going to be delocalized now. In this one also pi electrons are there moving from one carbon atom to another carbon atom. In this structure also pi electrons are moving from one carbon to another carbon atom. In this one also the pi electrons are moving from one carbon to another carbon atom. So by the delocalization of the pi electrons, means total we are getting as a 5 structures. Total how many structures we are getting? 5 structures. So according to that, if the number of pi bonds are increases, that resonance structures also is going to be increases now. If you see, ma, so just I'm making down. So first structure, second structure, third structure. So which one we can form as a more resonance structures? First option, second option, third option. I think so. You're not getting clearly, ma. So first 3. So which one is the more stable? Either third one or second one or first one. So third one is the more stable one.
Third one, sir, because benzene.
Why the third one is the more stable one? Means here.
Because of benzene and resin.
How many benzene rings are there, ma? Samhita?
2, sir, at the end.
2 benzene rings. Okay, 2 benzene rings are there. While having the 1 benzene ring, we are getting as a 5 structures. Then what about the 2 benzene rings? Means you will get as more than 5 structures only. Na? The number of structures are increases. their stability also is going to be increases. Again, next electron displacement reactions are there. There we will study about the resonance and all clearly. Now you got the clarity, all of you. All of you understand? So what is my
Yes, sir.
method, atomerism and all? Okay. Next. So last structural isomerism here. So last one we have a ring chain isomerism. Ring chain isomerism is very simple one. What is the ring chain isomerism? Any one of you? What is meant by the ring chain isomerism? Ring chain isomerism. So ring chain isomerism is nothing but open chain compounds are converted into the cyclic ring is called as a ring chain isomerism. What is meant the ring chain isomerism means here? Open chain compounds are converted into cyclic rings is called as a ring chain isomerism. Sir, which open chain compounds means alkenes and alkynes are they converted into cyclic ring. What is the best example means propene CH3 bond CH2 CH double bond CH2 sir. In this one, let us see ma. So propene is converted into cyclopropane. Propene is converted into cyclopropane. To exhibit the ring chain isomerism, minimum 3 carbon atom it has to be there. Minimum how many carbon atom it has to be there? Minimum 3 carbons it has to be there in a chain. Then only it exhibit as a ring chain isomerism. Okay, some examples I'll give. So next class we will discuss about all these points and all. Okay.